Very nice seeing you all. So today we are really happy to have you, Sandra, with us. So Sandra Cabeza, she's a co-responsible scientist at SALSA Stress Diffractometer, so at the ILL. And you will introduce the Neutron quality label. If I understood correctly, it's a quite important output from the brightness project. So we are really happy to hear more about it. So Sandra, the screen is yours.
Thank you. Oh, thank you very much for the kind introduction, and well, thank you for attending this half an hour. I would say crash course on these results from brightness regarding the pilot engineering effort towards this neutron quality level. So just please confirm that you are looking at the right PowerPoint. I hope
all good.
All good. So then now, so this is just the general agenda, so some background, why are we doing this, where are we starting from, and then where are we going, right? So thanks to this brightness common project and this pilot engineering results. And then I will let you know what we are planning also for the future, even after brightness, together with our colleagues in the European neutron sources. So to start with neutron strain diffraction characterization, we are not starting from zero. So this is a well-established method within the academic community. And there have been quite a bunch of efforts, let's say, even worldwide. So starting with this Versailles project called VAMAS in the 90s, where they actually proved this extrapolation from a diffraction signal to this strain characterization for polycrystalline materials. This is mainly for metallic materials. And then they proved basically what was the accuracy of those measurements also in terms of positioning and this strain accuracy as well. So all in all, they were able to reach a technological trend assessment in 2001 for, as you can see there, for this determination of residual stress by neutral diffraction. And that was basically a general guideline, right? So we had all the definitions, we had a best practice, which are the HKL planes to measure when we are in a monochromatic instrument, etc. So this is the starting point, if you want, of these standardization actions for neutron residual stress scanning. This has been actually updated recently in 2019. So they give some general approaches also for instrument alignment procedures, etc. But again, it's a very broad scope of definitions and equations. So from there, we're moving forward actually there's a network since the 2000 on the neutron technique standardization for structural integrity. This is basically an in-kind working group between neutron sources, synchrotron sources, industrials and academy. And this is to assess the reliability of the characterization of residual stress through diffraction methods. You can visit the website, they are quite active and we are right in touch and we perform a bunch of measurements, all of us, I think, every year. So then we came up with this Brightness 2 round to bring together a neutron ecosystem for the sustainable service with science with DSS. And here we are looking in the future. So we are looking to ensure the long-term sustainability of our user community, for us in particular, for the engineering community. And we recently started now, since last year, this European activity also for standardization of industrial residual stress characterization with easy stress. And this is, as it says, so it's more industrially oriented and the main focus is in these data exchange procedures and the comparison between synchrotron, X-ray and neutrons for the industrial data exploitation, basically. So if we start to go a little bit deeper in detail of this pilot project for common neutron quality level, here are the partners, and I wanted to show you all of them because so we have worked very hard on the definition of this level and also on the measurements in this multiple institutes. As you may imagine, so already coordination was an issue for those for all those measurements. And we demonstrated, basically, the first thing is that we can all coordinate, yeah, to such round-robin tests within a 3-year project. As you will see, so plenty of examples. So what was the aim? Now within this Brightness 2 project, this was included into a work package that was called a strategy to deliver neutrons for Europe and beyond. And there were 2 pilot projects on deuteration and engineering science. And what we wanted to build forward regarding the engineering community was this confidence of industry, right? So we have a method that has already an ISO technological trend assessment, standard round-robin tests across the world. Still, we are not well established within industrials. So they come from time to time, but they are not so confident, especially when we are to swap instruments, right? So therefore, we said, let's sit together, let's define the similar samples that we have for aligning our instruments and reporting this precision and accuracy of the values. Let's sit together, let's decide on a common sample, and let's start from scratch and this round-robin test to define basically a protocol, so a more precise guideline. So again, the ISO standard give us all the definitions, and here we have direct messages, how to align and with the common samples. And then let's define a common report template. So we all know what we need to report or what is important. So however, everyone does in a different fashion. And we wanted to harmonize also these reporting protocols. And finally, the aim was to demonstrate it, and this we did with industrial partners. So first of all, regarding this internal certification exercise, so basically what we wanted to prove is the position accuracy, right, of our gauge volume. So keep in mind that we are characterizing industrial components. So this could be from a few millimeters to a few meters. Samples, and where we measure is very important to assess this gauge volume positioning, as we said in the instrumental argot. So to that end, we define this common calibration sample that has a pin and 2 foils. I would explain you later how. And then we had one curved sample, this hollow cylinder sample, and this wall sample, which flat walls. And we will see now why, because we wanted, first of all, again, to be able to characterize this instrument gauge volume. So what is the actual size when we consider intensity distributions, divergence, etc., versus our nominal collimator or slit size. And then we wanted also to assess what is the precision of our alignment systems when we do entry scans in flat samples with an angle, in curved samples with an offset from this center radial line or also with an angle. And what you can see in the picture on the right-hand side is the final model of this calibration sample that at the beginning looked like a T. So nowadays it looks, as you see, like a pillar. Then on the top you have the same pin for alignment, and then you have 2 foils that are 90 degrees to each other. And this is to be able to characterize in transmission and reflection geometry without basically rotating your sample stage. So we did a bunch of measurements, all oriented to determine this uncertainty of the gauge volume position when we measure at different detector positions, for example, in monochromated instruments, when we rotate the sample in the sample stage, so on the table or hexapod, etc. So we did a bunch of systematic measurements, as we note here, to determine, first of all, what is the precision of the center of rotation, where our sample sits, and also what is that instrumental gauge volume that sits, so where is basically the optical center of the instrument, and how is it impact when I move one of the other critical positions as the detector. So what you can see at the bottom is basically the fit of 3 results. So we measure the gauge volume at 3 detector positions, and we found out those offsets from the center of the gauge volume to the center of rotation to the sample stage. So that translates into an uncertainty of positioning that may translate into an important uncertainty of stress determination. So what we came up with as a conclusion from this first exercise from the 4 institutes is that, okay, so now we are aligning more efficiently because we share basically a common protocol and a common sample. So no one has to think in parallel new fancy things. So we can discuss these things together, fabricate these things together, and then report also the errors, let's say in the same fashion. Of course, we are compliant with the previous exercises, in particular in those ISO guidelines. It is stated that for a proper characterization, we need to be better in that positioning than the 10% of the size of the gate volume, and we were better than that, we can say. And as you can see, we measure quantitatively what was this accuracy and the agreement when we rotate different motors at the instruments. So regarding the entry scans, however, we observed that for flat samples, we were within this accuracy. However, for curved samples or those tilts exercise, some software has some, let's say, errors above 300 microns, and therefore we are studying into that. So how to improve, for example, the software regarding those cases. So all in all, after that exercise, what we came up with was this nice label, first of all, this so-called Neutron quality label, the symbol and the report. So more specifically, all the values that we need to report for this traceability of results, so that the next instrument scientist or the next beam time campaign, you can retrieve the main metadata that you need from the instrument setup, etc. And of course, the results. So that's basically the summary that it's included in this NQL. It's also labeled, so for each instrument it has a code number, so you can retrieve it from previous measurements. And let's say it's also more user friendly, so the industrial users in particular don't need to look at different formats or different information on different sizes, pages of a report. And this is actually, let's say, for them extremely useful when they are to exchange from one instrument to another, so they are more confident in this sense. So what we did basically is this industrial examples with EDF and with Airbus. And in summary, so for the first case, we wanted to prove this bulk scan analysis. So this was a big cylinder of 350 millimeter diameter, 30 millimeter thickness. So this is something you usually have to cut to measure if you want to characterize in the lab or sometimes at synchrotron facilities. But this is something we can handle with neutrons. And so from the round robin test, we saw complementarity, of course. So every instrument, it's, let's say, optimum for one case, but we could all deliver similar results. We could all report in this same fashion with this NQL templates. And so we proved that we could actually enhance the access, the industrial access to multiple facilities. For the second case, as I said, this was a near surface scan. So we had a surface that was treated here in blue. It was a tensile sample with a 10 millimeter thickness, in this case of aluminium. And this was laser shock beam. And we did the entry scans to observe what was the residual stress state, hopefully in compression near the treatment, and then towards zero in the bulk in the center of the sample. So, however, for the, as I said, for the spatial resolution and the assessment, this was not good enough. This was not compliant yet regarding the software data treatment with the ISO standard. So we keep this sample for the future experiments and enhancement of the software regarding these entry scans for the group. So if I am to conclude what we learned from this pilot projects, so not only the science, engineering science, but also the iteration one, I think we all found out that the collaborative method has been, of course, a great advantage, both scientifically and economically. So our community has more access to all facilities. They can exchange, then we can also extend these capabilities, and we can enable experiments that we were not able to do before. So if I even may add, I would say it's the only way for me to go forward if we consider all our shutdowns and if we really want to assess, well, to provide this continuous access, which is sometimes the main obstacle for industrial application of neutron measurements. So that's why I put here the pyramid. So we are based on this continuous access mode for neutron strain scanning in our case. We are guaranteeing that traceability and common processes, let's say the quality of those measurements, thanks to this NQL exercise and NQL report, where we have proved already with this particular industrial cases, this complementarity and exchangeability of results. So, and again, the main or the ultimate objective of the brightness is this long-term sustainability of the community. So I think we have proven here a very good example that this is feasible when we work together. So, and then if I summarize what we are planning for the future, so just to tell you that the NQL is a trademark since last year in Europe and in England. We are still awaiting decisions in some countries. So officially the way we coordinate this, which was the simplest way to coordinate when we discussed within the group, is that ILL owns the trademark and we license it to the colleagues that have done such exercise to prove that they are within that accuracy, etc. And we give them the license for 10 years with a signature. And then what we are expanding now, we are discussing about this method developments, instrument developments, industrial applications, etc. So the idea is to hold one group meeting a year. Of course, this will be for the moment in-kind contribution from each partner, as we have seen in other cases. And we have been discussing for a long time. We will see if now that COVID is a little bit more relaxed in this atmosphere, maybe a workshop dedicated to neutron and synchrotron residual stress every 2 years. And we have drafted already a single, let's say, entry point website that it's called NEUSScan, that stands for Neutron Strain Scanning, where we summarize a bit of the method, a bit from every instrument, and of course the NQL. And so if you want this for users, it's also easier maybe to grasp when you have the 4 instruments to compare in a single website, when you have all the dates from the proposal rounds in a single website, etc. So what we plan to discuss also in June, when we will meet in Lund, is how to improve those entry scan codes that we have seen that for curved surfaces are not as good as required by this standard. We are also working together into the definition of common diffraction elastic constants lookup table, because this is a very old knowledge and materials evolved, and this has a very critical impact into the stress calculation afterwards. We are also observing in all facilities the same trend, that it's improving and developing new in situ characterization, so in particular for high temperature characterization. So we plan to share sample atmospheres in this sense. So this has been done with regards to other sample environments. So we want to do the same for strain characterization. And there's a small working group on, of course, on additive manufacturing, and let's say a more fundamental theoretical group on this translation of uncertainties to stress error. And with this, I leave you, of course, my contact, but I hope we can get some discussion now and some questions. Thank you very much.
Thank you very much, Sandra. It was very interesting. I have just a burning question, and then I will give the floor to the audience. You mentioned this industrial application with EDF and Airbus, and so I was wondering how you worked with them and what was their feedback?
Yeah. So in principle, we contacted them, let's say at the scientific level, because we are in touch with them for other projects or for other industrial measurements that we have performed together. So in this case, it was us defining the sample that we would need to prove our case. So we wanted this bulk sample and this surface treatment sample. So they are already familiar with the method, which for us is, let's say, more efficient regarding the time scale also for this project. And the feedback was very good, because in the end, what they do is that they compare this against their simulations. So, and this was very good feedback in both cases, and that's why we keep collaborating with them in our following project. Indeed, with EDF, they are now within our Easy Stress consortium, and they are also within this net community for in-kind contributions. And I think, so all in all, I think the biggest challenge here was not to prove the results. I think we knew, I mean, we design our instruments so that we get the good results as well with this accuracy and this precision. But I think all in all, the best example was that we were able to measure this within Europe and even in South Africa. So we were able to coordinate these measurements, to agree on the measurements, to agree on the reporting, so that then for the industrial is very light to read through. Yeah. So this was also one of the messages we got after the exercise.
Very interesting. I'm curious to know if you're going to have more requests from the industry after those two tests. Nikolai, you have your hand raised.
Yeah, thank you. Hi, Sandra.
Hi, Nikolai.
Thanks for the presentation. Looks very good. I was just curious, the Neutron quality label, do you correlate that in any way with the with ISO standards or the work in CEN, or is it an initiative only from the Neutron facility side? Yeah,
so that's a good question. I tried to explain a bit at the beginning, but I was maybe very fast too. So the ISO standard stays at the bottom of this pyramid, right? So the ISO standard gives us all the definitions, explains the method, explains this extrapolation from diffraction to stress, and gives a very general guidelines. So we are standing on that guideline. And now what we propose with this NQL is, as you said, so we propose this kind of internal certification, right? So we said, okay, let's define these common samples. Let's define this exercise, that it's a very systematic exercise. So it's nothing very fancy regarding science, we know, but this is the way to benchmark all together and to compare all together our positioning in this case. And also our reporting, because in this NQL, we give some more specific guidelines. If you want, in the general ISO, you have all the definitions, everything you can do, but it doesn't tell you that, for example, you have to realign, in our case, in a monochromatic instrument, when we change to theta more than 20 degrees position of the detector.
And actually, there's other standards defining what you need to do when you do round robin test and this proficiency testing. So I was just curious if you had a look at any of those. So basically saying, if you want to do round robin test, how do you do that according to a standard? So it's not a standard on the technique, it's a standard about how to conduct round robin test.
Yeah, okay, now I get your point. Right, so we were not aiming particularly at a very, let's say, it's not a round robin in that sense. Okay, so let me rephrase then. It's not a round robin in that sense. It's we want to share the same sample so that we report, so that we can compare the errors, the instrumental errors, yeah, in the same fashion with the same calibration samples. So maybe that's more clear.
Oh, and I mean, the initiative makes perfect sense as an also internal tool among Neutron facilities to make sure that the machines are performing as you expect. Great, thanks.
Any other? Yeah, Sylvia?
Yeah, I have a question because within the Knowledge Project, we are preparing a booklet of successful case studies between industry and science infrastructure. So I was wondering, maybe we could describe one of the case studies that were presented in here. Would that be possible to get to you, to get contacts to the company so that I can talk to them and get some information?
I guess
some logos, pictures.
So I'm not sure. The last time I checked the website last week, the deliverable is not yet uploaded on the Brightness website. It's deliverable 2.6, but I can forward it once it's online, I guess. And for the contact with EDF, I think there's a press release. It was shared on the Brightness website, also with EDF. And there might be the contact of Vincent. If not, we can put you also in touch.
Okay, thank you.
Margaret, I can already anticipate your answer. Go ahead.
What do I need to say? Okay, we're still waiting, Sandra, for the Commission to approve the deliverable, and once it's approved, we can then it then goes a public. It's public deliverable. So, but that won't happen until June at least, the end of June.
But that, I guess, that doesn't prevent
it doesn't prevent sharing
on this specific case as well. So
yeah.
Okay.
I have a question. Sorry, probably it was said. Hi, everyone. It was already clarified at the beginning, and probably I missed them. For this Neutron quality label, all the Neutron sources partner in brightness participate or not? This I missed it.
Okay, so it's here at the bottom basically. So the
just the one at the bottom, and
only there, yes.
And other Neutron sources, if they want to apply and be certified with this Neutron quality label, which is the process that they have to follow?
Okay, so up to date, because we haven't had much time to do the outreach yet as scientists, unfortunately. But so up to now, we have, it's been myself doing the contact with ANSTO and PSI, telling them what we were preparing and asking them for beam time. So hopefully we will have some beam time this year, because again, it's not a fancy measurement, it's a very systematic measurement with a common sample, but hopefully they will run it this year to join us. And the idea is that with the website that I said, and with this kind of outreach, we get also requests. So it could be both ways.
Okay, no, I'm asking because I'm industrial zone officer of CERIC, and I was thinking about Budapest Neutron Center, that I know that is partner in brightness, and okay.
But we are in close contact with them for easy stress. So we also told them we're also So I forgot to say, but we are also in contact with the colleagues in Budapest. Okay. But we still don't know when the measurements will take place. Yeah, so this is under in-kind contribution, so they have to find this internal time, etc. So that's why we can push, but we have to wait.
Okay, I will push also from my side.
Thanks.
Thank you.
Is there any more questions, comments, ideas, or Sandra? Margaret?
Okay, I just wanted to ask Sandra, what would be the best case for the NQL? You know, what would you like to see what would be the biggest impact it could have, particularly bearing in mind that the enriched audience is different to the brightness 2 audience?
So for me, is this continuous access? Yeah. So first of all, if we have proved this complementarity, exchangeability, and traceability of results, for me, this continuous access should help to improve industrial research at Neutron facilities, hopefully. And then on the other hand, is that I think for us all is easier to look at the same template report and use all of us this report to exchange the data between us and also with users and also with industrials, because it reads once you have seen it twice, 3 times, then it reads faster, right? So also for us, for instrument scientists, this is also very nice and helpful.
So we're calling all the Neutron facilities or sources to reach out to you. And could there be eventually something similar done with the other sources?
What we discussed at the time, so the name of Neutron quality ladder, so you see there's no strain involved in the name and no stress, is that eventually some SANS colleagues can define themselves what is their internal certification, what is their templates, so which values they have to report in such a template, etc. And I think the best case scenario is actually that we export this not only for the Neutron strain community, but to the rest of the Neutron community. Yeah, we'll see. I just leave the floor for the other scientists.
So that's an invitation to all the sources to reach out to you and evaluate the possibilities. Okay, so if there's no more questions, I mean, we are on time, so perfectly on time. So I thank you all very much for your participation. It was very interesting. Thank you very much, Sandra, for your time. And I invite you all to join us again on the 2nd of June, where we will have a presentation from Ale Shala from Eli. And just stay tuned for more information on the topic. It's currently being defined, so just a small teaser. And so have a great week, month, day, and I see you on the 2nd of June.
See you.
Thank you.
Bye.